I'm Amira, and I'm going to present about background of Blaise Pascal. So Blaise Pascal is a French mathematician, physicist, and inventor, created at Pascaline in 1642, one of the earliest mechanical calculators. So it was designed to add and subtract using gears and wheels. So it was also considered an early step toward modern computing devices. His work influenced later developments in computers and computational logic. So Pascal programming language was later named in his honor. So for the next slide, I'm going to present about the machine of Blaise Pascal. So Blaise Pascal machine is Pascaline calculator. Blaise Pascal machine, which is known as Pascaline, was one of the earliest mechanical calculators ever invented. It was designed to perform addition and subtraction, aiding in arithmetic calculation. Next is the design of the Blaise Pascal machine, which is Pascaline calculator. So the design for the Pascaline calculator was a mechanical machine made with wheels, gears, and dials. It was enclosed in a metal or wooden shell. So the device looked like a box or maybe like small cabinet. Its size varied by model, but was generally small enough to fit on a table. So Pascal created several versions of the Pascaline. Each version has its own unique arrangement of gears and wheels.
Hello and good evening. My name is Sharizala Natasha binti Nizam. My metric number is 2024783441. And today I will be presenting how it works. We start with the input. The user rotate the disk to represent the desired number. And then we started by adding the number engaging gear inside the Pascal line. Causing corresponding number will rotate, thus incrementing the display value. And then for the subtraction, Pascal devised an advanced technique using complementary integer. Instead of directly subtracting one number, user input the sum of the number to be subtracted. And then the result of the calculation would be displayed on number dials of the window on the Pascal line front panel. This makes the user to read the final result directly from the display. So this is the advantage and disadvantage of Pascal line. For the advantage, we have the increased speed and accuracy. It was innovation in mechanical computing and user friendly. For the disadvantage, it has a limited functionality. The cost is high and the construction is too complex and the size is too big, make it less portable for anywhere.
Next is the contribution of Blaise Pascal machine known as Pascaline calculator. So Pascal defined a convenient tabular demonstration for binomial coefficient called Pascal's triangle. He expresses the number in the triangle which is by recursion. Blaise Pascal invented his numerical wheel calculator called the Pascaline. His latest scientific work was on cycloids. In 1658, he solved some problems that occupied many mathematicians, in particular related to the area and volume created by a cycloid rotation around its axis.
Assalamualaikum. Hello, my name is Zahra. I'm going to present about Gottfried Frege, which is about state reckoner on crater. Gottfried Wilhelm Leibniz was a German philosopher, mathematician, and political advisor, widely regarded as one of the most influential thinkers in history. Born in 1646, he made groundbreaking contributions across many fields. Leibniz independently developed differential and integral calculus, and he also created the Leibniz wheel, a key mechanism used in early mechanical calculators. He introduced the binary number system that later became fundamental to modern computing. Beyond mathematics, Leibniz explored logic, metaphysics, and theories of knowledge, and theories of knowledge, producing works such as the modalology. His idea and innovation continue to influence philosophy, science, and technology today. Here we have the step reckoner, an earlier mechanical calculator created by the German mathematician and philosopher Gottfried Wilhelm Leibniz in the 17th centuries. This device was groundbreaking for its time. It was one of the earliest machines capable of performing basic arithmetic operation automatically, something that had never been achieved with such precision before. The step reckoner could handle four main functions, which is multiplication, division, addition, and subtraction. With its system of rotating drums and gears, it represents a major step forward in the development of automated calculation and paved the way for future computing knowledge. Next is about design. The step reckoner was built around a series of cylindrical discs or drums are arranged along a single axle. Each dial represents a digit from 0 to 9, allowing users to set the numbers they want to calculate. This dial could be adjusted manually using knobs or levers. Much like modern digital displays, the step reckoner uses positional notation system, meaning each dial represents a different place, where such as unit, tens, and hundreds. Inside the machine was a complex system of gear. Inside the machine was a complex system of gears. When the user rotate the input dials, these gears translate the movement into arithmetic operation. This clever mechanical design allowed to step reckoner to perform calculation accurately and automatically. Next is about how it works. To operate the step reckoner, the user begins by setting the numbers using the cylindrical disc or drums. Each drum is adjusted manually to represent the digit of the calculation. Once the numbers are set, the internal gears take over. These gears perform the arithmetic operation based on the position of the drums. For addition and subtraction, the gears simply add or subtract the digits. The machine automatically handles carrying and borrowing, ensuring accurate results without extra step from the user. Multiplication and division work a bit differently. The machine uses repeated addition for multiplication and repeat subtraction for division, allowing it to handle more complex calculation mechanically. When the process is done, the result appears as on the output dials, ready for the user to read. Afterward, the user reset all the drums back to 0 to prepare the machine for the next calculation. That's all from me. Thank you.
Assalamualaikum. My name is Nurul Iman Zawana binti Zapri. In this slide, I will present about advantage and disadvantages of step reckoner by Gottfried von Leibniz. For advantage, first is able to perform multiple operations. The step reckoner could perform all four arithmetic operations, which are addition, subtraction, multiplication, and division. It offers greater versatility compared to earlier calculators that only handle basic calculation. Second is increased efficiency in calculation. It enables more efficient processing of complex calculation, proving especially valuable in fields requiring precise mathematical operations such as astronomy, engineering, and finance. Third is inspiration for future developments. The design and functionality of step reckoner inspire future advancement in mechanical computing, demonstrating the potential of mechanical devices for complex operation, and paving the way for the development of modern computer. Next is for disadvantage. First is mechanical complexity. The innovative yet complex step drum mechanism in the step reckoner led to issues like jamming and misalignment, causing errors in calculation. Second is difficulty in use. Unlike simpler calculators, the step reckoner's sophisticated design made it less user-friendly, requiring a true understanding and careful handling for accurate use. Third is reliability issues. That precision needed in manufacturing. Each component meant that even minor imperfection could disrupt the entire calculation process, affecting the device's reliability. For the next slide is contribution of Gottfried von Leibniz. First is calculus. Leibniz, a renowned mathematician, developed differential and integral calculus independently from Sir Isaac Newton. This notation of integration and D for differentiation is still used today because it makes solving complex problems easier and more systematic. Second is binary number system. He made significant contribution to binary number system and integration. He introduced the idea of using only two digits, 0 and 1, to represent numbers. This concept became the foundation of modern computers since all digital technology relies on binary code to process information. Second is philosophy and logic. He renowned 17th and 18th century thinker, made significant and diverse intellectual contribution. Leibniz contributed to philosophy and logic by exploring ideas about reason, knowledge, and metaphysics. His work influenced later philosophers and have shaped modern logical systems. Lastly, for the conclusion, Pascal devised the only capable of basic tasks, improved calculation speed and accuracy, showing the potential of mechanical computing. While for Leibniz, calculator had the ability to perform all four basic maths operations, marking a major improvement despite its complex design and high upkeep costs. Thank you, mates.